Hi guys, so today I'll be running through with you a summary on Maclaurin series. The first thing that you have to take note of is of course the Maclaurin series expansions. The formula given below can actually be found in your MF26, so you can just directly copy from your MF26 booklet in the exam. So before we actually start to understand this formula, we have to understand the notations within it. Let's start with f of 0 followed by f prime 0 and of course the respective f primes. What do all these actually represent? So f of 0 basically means when I sub x equals 0 into f of x, and over here f prime 0 basically means I'll have a dy dx and I sub a 0 into it, and of course for the remaining d2y dx squared sub x equals 0, and so on and so forth until the last term over here, dny dxn x equals 0. Okay, so let me just give a quick example on how we can actually do this. For instance, if I give f of x to be e to the power of x, all right? So how do we apply this formula then? We of course must find the first derivative, second derivative, and so on until the question stops you from doing so, okay? So I will say when x equals 0, f of 0 will be e0, which is 1, okay? Then what happens when you differentiate ex? Differentiate it once to get the first derivative, it will also be ex, right? So f prime 0 is e0 again, which is 1. So if I keep going, f prime of x equals ex again, because when you differentiate ex, nothing happens. Okay, so f prime prime 0 again is also 1. Okay, so you just keep going until the question limits you from doing so. Okay, the second concept that we need to understand in Maclaurin series, okay, is also binomial expansion. Okay, of course you also have to know the rest of your standard series, for instance your sine, cosine, ex ln 1 plus x. However, the more important ones would be binomial expansion. Okay, so for second part we talk about standard series, okay, all of which you can find in MF26, so you do not need to memorize them, okay? But what is more important here, the third point, is your binomial expansion. This is something that you might have learned in additional math in O levels, so now it's a recap on something that might be familiar with you, okay? This formula again can be found in MF26, so do not worry about it, okay? Do understand that the constant here must always be 1 before you can proceed to apply the formula, okay? So I would just like us to take note, okay? Constant must be 1. So now let's proceed to write out this formula. It will be 1 plus nx plus n times n minus 1 over 2 factorial times your x squared plus, if we keep going, n times n minus 1 times n minus 2 over 3 factorial x cubed, of course, plus dot dot dot. Okay, so the important parts here are your coefficients, so it's with n times n minus 1 divide 2 factorial and so on and so forth. Okay, so just to test your understanding, if I were to increase um the 1 2 3 4, the fifth term, which is x to the power 4, it'll be n times n minus 1, n minus 2, n minus 3 divided by 4 factorial, okay, x4. Okay, so this is the pattern that it follows. However, it must be noted that the range of values of x lies between -1 and 1. Okay, because this is what you're given. However, if you recall your chapter on inequalities, you can actually simplify to this. Okay? So with that, we have come to the end of the last part of Maclaurin series. Okay, and this last part is where the applications start to come in. And this part here is called your small angle approximation. Okay, so for small angle approximation, we will be working with the three trigo values here. So the basis of this is if x is small. Okay, given that x is the angle, if x is small, we will have the following. Sine x is approximated to be x. Cosine x is approximated to be 1 minus x squared over 2. And tangent x is approximated to be x. Okay, so with that, I've come to the end of the Maclaurin series summary.